Hi guys, welcome back. This is Professor Hank, and in this video I'm gonna walk you through another Python programming example, right? So specifically, I'm gonna demonstrate and talk about how to solve a problem, using modular programming. We're gonna take a look at our three-step process to get that thing done. There's gonna be some flowcharting that's gonna be included in that design process. To solve the problem, we're going to write some functions, we're going to do some text file input and output, we're going to do some basic string processing. So let's get to it. So let's start off by reviewing our three-step process. Step one, understand the problem. Do a little bit of requirements analysis. Make sure that you know what it is that you're supposed to be doing here, right? Step two, come up with a plan to solve that problem. We'll use a little bit of flowcharting here to help us out, and we'll think. Right, we'll think through it, come up with a plan. Might not be the best plan. We might have to go back and revise it if it doesn't work out for us. But we're gonna have to come up with a plan. We're gonna want to think this thing through, so we're not just mindlessly coding a bunch of crap hoping that it's gonna work. Okay, and then step three is going to be to implement that solution. Now you might come up with a different plan than me. You might write your code slightly differently. Right? There's always multiple ways that you can write a solution to a problem, or multiple ways that you can come up with algorithms for multiple different types of algorithms you can come up with to solve a problem. Fine, right? As long as it works. But in this video, I'm going to try to come up with a plan that illustrates those concepts that I teased you with at the beginning. So it might not be the most efficient plan, it may not be the best plan, but it's going to be a plan that works. We hope, right? Let's try it out. So step one, understand the problem. Convert binary numbers. Write a program that converts a text file containing binary numbers into a file containing decimal numbers. The program should ask the user for the name of the file and then convert the file. Binary numbers in the file are 4 bits long with one number per line, right? So what do I have? Okay, what do I have? I know that I've got myself a text file, right? I got a text file, and there's 4-bit binary numbers on each one of those lines, right? So you can imagine that my text file looks something like this: 0011, 1001, 1100, 1110, whatever, right? So I know it's also a text file, so each one of those lines is actually a string, right? So what I need to do is I need to convert each one of those lines into an actual decimal number, right? It sounds really complicated, but let's just break it down. Let's take it one step at a time. Now when I look at this, I'm thinking in my head, well, each one of these lines has to be converted into whatever the decimal number is, right? So that's going to be a basic process that's going to be repeated over and over and over and over again, right? So anytime you have logic that is repeated, that's going to be repeated in your program over and over and over again, those are good candidates for functions. They are a sub-function or a sub-program for your program. There's some logic that you want to be able to repeat over and over and over and over again, right? So I think that's where I'll start, right? I'll start by being able to have my program convert a binary string, right, or a string that represents a binary number, into a decimal string, right? So that's what we're going to do. Now, how are we going to do that, right? Well, let's think about that, right? So if I've got this 4-character string, right, what I'm thinking is that I need to iterate over each individual position in that string, right? And the first position is the 1's place, the next position is the 2's place, then the 4's place, then the 8's place, right? So as I'm iterating over that string, every time I see the character 1, I need to, for that position, add 1 to some counter, right? Or add the number that goes with that position to some counter. So I could start off a counter variable and set it to 0, right? And then have some kind of loop that just moves to that string, examine each position. Well, there's a 1 there, so then we have to add 1 to our counter variable, right? We move to the next position. Well, there's no 1 there, so just move along. Go to the next position. Well, there's no 4 there, so just move along. Go to the next position. Well, there's a 1 there. Okay, well, then we have to add 8 there, right? And so when we're done, we've got a counter variable that has 9 in it, okay, which is what that's what this represents. But I need that then to become the string 9, right? Not the integer 9. So that tells me that, I'll have to use that string function on my counter variable. That's cool. We can do something like that. So let's encode this in a plan, right? How about we have a flowchart for this? Okay, we'll use flowcharting in this video. So this thing's going to be a subprogram, and I'm going to call that subprogram, what should I call it? Convert, I guess. Okay, so we'll just call it convert, or maybe convert it. How about that? Okay, now let's think about some of the steps that we would need to make this work, right? Well, I know for a fact that I'm going to need that counter variable, right? Counter, and I know that I need to initialize that to something, so I'm going to initialize it to 0, right? So I know that I have to have that. And then I know that I'm going to have to start, for the string, I'm going to have to start at the very first character here, right? So if I do that, and I move in this opposite direction, right? Think about in the strings what the valid indexes are. Remember, strings are sequences, right? So what are the valid indexes here? What would the indexes be? 0, 1, 2, 3, okay? So if that's the case, and I know for a fact that there's 4 digits, I could actually do my iteration from left to right, right? I only need to have 4 repetitions because I know that they're 4 bits long. It's right there in the problem description, right? So what I could do is maybe something like this, right? I'll create some kind of a variable, maybe just I, right? I'll set I equal to 0. Okay. Now if I set I equal to 0, then I'll be able to move from left to right. Okay. So how about this? Okay. So while I is less than, let's see here, that's 0, 1, 2, 3. So while it's less than 4, right? Well, I is less than 4. Well, that's true. What are we going to do? Okay. Well, I'm thinking about this 8, 4, 2, and 1 right now, right? So what I'm thinking is that maybe I'll start some temporary variable. Let's revise our flowchart here, right? Maybe I'll set some temporary variable. I don't know, maybe we'll call it factor or something, right? Let's call it factor. I'm just making that name up. We'll set that to what? 8, okay? Because that's the value of that position, right? Now, once I've done that, now I'll have my decision. I'll set up my loop here, right? So I'll say, well, while I is less than, what would it be, 4, right? Because there's 4 positions. While that is true, then what? Right? Then what I'm going to do is I'm going to check to see if the ith position of the string, right? So I'll just say string of I, right? I'll just use that name string for just to represent, whatever this is, right? That right there. So at the ith position, what are we going to do? Okay. If that is equal to 1, then what do we do? Okay, well, if that's equal to 1, then I'm going to add to I, or not to I, sorry, to counter, right? I'm going to add to that my factor. Okay, if I is equal to 1, then add to counter factor. Okay, add to counter factor. Okay, so if that's true, we're going to do that. Okay, and then we're going to proceed on. Okay, so we'll start off at the 0th position. If that's a 1, add factor to counter. Okay, but if it's not, don't do anything. Continue on with your life. Okay, now once we've done that, we got to move to the next position, and factor's got to get smaller, right? Because we're going from the 8th position to the 4th position to the 2's position to the 1's position, right? So we'll go ahead and we'll increase I. Okay, but then we got to divide our factor by 2, right? So divide factor by 2. Okay, and then once that's done, we're going to go back and see if we need to have another iteration. Okay, but if this is false, if I is not less than 4, then we've gone through the entire string, and we've got the counter variable now. That's going to hold our decimal version of this, right? But remember, that thing's going to be an integer. So then we'll have to convert counter to a string. Okay, we'll do that. And then we can return the string, right? We'll end up returning it. Return that string. Oops. Return that string. Okay, so that's what we're going to do. And that will be the end of our function there, right? Of our subprogram. So before we continue on with our plan, let's just see if that thing works. Let's go code that and try it out, see if it does the job. All right, so there's our plan for this function on the left-hand side of the screen, and then I got idle open on the right-hand side. So let's define that function, convert it. Okay, now convert it's going to need a string, right? It's going to need that bit string. So I'm going to have a parameter in here so it can accept that string that represents the binary number. Okay, and so I'll just call that parameter bit string. Okay, so let's just go one step at a time, converting our plan into code. So I need a counter variable, okay, or a variable named counter, which I'll call 0, right? And then I have I, which I'll set to 0, and then I've got factor. Okay, so we'll set that to 8, and now we're going to have a loop. So while I is less than what? 4. Okay, what are we going to do? Well, if that's true, then what we're going to do is we're going to check to see if that string, right, at the ith position is equal to what? Not 1. Because remember, this thing is a string, right? It's a string that represents a binary number. So it's got to be compared against 1, or the string that contains just the single digit character 1. Right, now if that is true, if it's equal, then what do? We add to counter our factor. Okay, and that's it. Take a look at the plan, right? All right, so if it's not equal to 1, then we just to the character 1, then we're done. That if statement's over, right? It's a very simple if statement there. Okay, now next up we have to increment our I, right? And that's going to move us to the next position in that string. And then we have to divide our factor by 2, right? So that's the end of the while loop. Okay, now what do we have to do after the while loop? We'll convert the counter to string. So can just do something like this. counter equals string counter. Okay, and then we'll go ahead and return. Right, so I think that'll work. Okay, now let's test it. We'll know for sure when we test the thing. All right, so we'll pass to it 1001, right? So answer equals convert it, pass it the string 1001, okay? And then we'll print answer. Right, let's see what we get. There we go, 9. Now the question becomes, why is it 9.0? Right? Why is it 9.0? Well, if we take a look at factor divided by equals 2, what is that? That is floating point division. Right? So let's make a slight change here, make that integer division, and see then if we get rid of that 0.0, and we do. Right? So there's the first part of our program. Let's try a different string here just to see if it works. Right? We should see 3 there if it does, right? Does, and let's try 1111. That should show us what, 15, right? There you go. And then let's see if it converts 0, right? And it does. All right, so we're back. Let's continue on with our next subprogram, our next function. What are we going to need, right? Well, we have to be able to open the file, right? And we have to be able to read in, you know, the contents of that file. Okay, so that's what we'll do next, right? So I'm thinking what we'll do is we'll create a subprogram, a function, right? And I'll call that one load file. Okay, right? So this thing is going to need to open a file, right? And then it's going to need to read the lines in the file. Okay. And then it's going to need to close the file. Right? And then it's going to need to return the lines. Okay. Now, cool thing about this is, that, and then this is done, is that in Python, we've got a file object method that can read all the lines of a text file, put it in a list for you, all in one action, right? And so then we can just return that list. That's what we'll end up doing. Okay, so let's go ahead and get that done. One thing though that just occurred to me is that the way that we wrote our function, the converted function, is that the string that I tested it with didn't have any new line characters. So we're going to have to deal with that. We'll have to go back and modify our converted function, but we'll do that here in a second, okay? So read the file lines, close the file, return those lines. So let's go do it. Okay, so let's take a look at that converted function again. And we had a string, we passed a string to this thing that didn't have a new line character in it, right? So my initial thought here a second ago was that present a problem for us, right? But will it now? Now that I think about it, maybe not, right? Because if there was a new line character in the string, right? Well, our loop still finishes after 4 repetitions, right? So 1, 2, 3, 4. So I actually don't think that it's going to be a problem now that I think about it again. So let's see what happens with that. Okay, let's go ahead and run it and see if that blew anything up. Actually, it didn't. Yeah. So, you know, it doesn't. It's not going to pose a problem for us at all because our loop only iterates 4 times. Now, whether there's a new line character there or not, don't matter. Now, why does that play into it, and why does that play into the calculus here? Because remember, the file of binary numbers each one of those numbers is on a separate line, right? Well, how do you make different lines in a text file? You have to have a new line character at the end of a line, right? Otherwise, everything would be all mushed together. And when Python, when the file object reads in a line, it reads in everything, including that new line character, right? So our converted function isn't going to have a problem with taking, a string with a new line character and do it the way we have it right here. So we'll just go ahead and move on. All right, so let's translate our plan there into another function, right? So this is going to be the load file function, and we're going to need a file name, okay? And we're going to need to go through all those steps, right? So let's go ahead and open the file, right? And we're going to open it for reading, okay? And we have to assign to a variable a reference to that file object, okay? And then we know that we need to close this thing when we're done. Okay, now we need to read the lines. The file object method read lines is gonna do that for us, right? So fo.readLines, okay? And so what does this thing do? Right, well, it returns a list of the lines. So let's go ahead and just create some variable to hold that list or to reference that list. So we'll say, we'll just call it lines. Why not? Okay, and then once that's done, go ahead and return the lines, right? So let's plug this in and test it. Okay, so result equals load file, and then I created a text file on my desktop called numbers.txt, and that's correctly formatted. So we'll just run that, and then we'll print a result. Right, so let's try it. All right, so there you go. So there's the list that contains all of the lines that are read. And actually, that last line of the file, that last number, I didn't hit an enter after it. So let's fix that. Okay, then we'll save this, then we'll go back and retest it. Okay, so there you go. So you see what I'm saying? There's the new line characters after each one of them. But we know that our function, the converted function, we know that it works on strings whether there's a new line character or not. So it's not that big a deal, but this is just something that I was thinking about, right? So we now know that our load file function can get us a list of in the file. We know we can convert them one at a time. We know we can convert a string that contains these zeros and ones. So what do we have left? Well, now we got to go back and we have to create another subprogram that is going to write everything back. So back to the drawing board, right? So let's call this save file. Save file. All right, big old over there. So what do we got to do, right? We're going to have to open the file for writing, right? Then what are we going to have to do, right? We're going to have to go through that list one at a time and convert each one of the lines in that list that we just got from load file, and we're going to have to convert it and then write it to the file, back to the file, okay? So we'll open the file, and so the inputs to this function are going to be the file name, right? And also that list. That's what I'm thinking. That list of numbers, right? Okay. So for each one of those items in the list, right, we're going to have to convert and then, right, then write. So we'll have a little counter variable, and then so long as I is less than the length of our list, right? Gross diamond, sorry. So long as that is true, then what do we do? Well, we have to call our converted function, right? So we're going to call convert it, use convert it, right? And we're going to pass to it the line in our list, right? The ith line of our list. Okay. And then we're going to take what it returns. Okay. Whatever it returns, we're going to write that, right? Return value to the file, right? And then we have to increment our I plus equals 1. Okay. Once that loop's finished, we've converted. We've done all the conversions, and we finished our writing. So there's nothing else to do here really, other than close the file. This doesn't have to return anything. Close the file. Okay, and then this is done. All right. So let's add that function to the pile, right? So let's define save file, and we have to pass it the file name that we're going to open and the list of numbers, right? So I'll call this numbers list. How about that? Okay, so what do we got to do? Open the file for writing this time. Okay, and we have to assign the file object to a variable. Okay, and then I know when I'm done, I'm going to have to close the file. Fine. Right, and then I got that I variable, I equals 0. And so then while I is less than the length of numbers list, what do I have to do? Right, well now I got to call convert it. Right, and what am I passing to convert it? The ith item in numbers list. Okay, I'm going to do that, and then I have to place that somewhere, so I'll call this DN for the decimal number string, DNS for decimal number string, right? Okay, once I've done that, then I can do a write, right? So I've got to do my write the value to the file, so we'll say write, okay, and it's going to be that DNS string. But we need to have every single decimal number on a separate line. Right now, remember we talked about this, where if you look at our converted function up there, there's nothing there that puts a new line character at the end of the converted string, right? So we're going to put that here now. Okay, so we'll do that. And then we'll set our plus equals, or we'll set our I plus equals 1, right? We'll add 1 to it. Okay, and once that's done, once the loop's finished, well then we're done with the file. So we'll go ahead and we'll close the file. All right, so now for this last function here, oops, I already did that, didn't I? For this last function here, the only way I can really test that is really just to run it. This is the last little piece of the function, right? Because I'm going to have to get the numbers in. I'm going to have to load them in and then do the conversion. So we'll hold off on that test here for a second. Let's go back to the design page here for just a second. So we've got plans for our 3 subprograms. Save file is untested as of this instant, right? Because we have to finish one more part, right? We're going to need one more main subprogram. Well, I say main subprogram, but what we need is the mainline logic for our program. Okay, so what's that going to have? Right, well, remember, we still have to ask the user for the file name, right? Okay, so we still have to do that. Okay, once we have that file name, then what do? Then we call load file, right? We're going to pass that file name. So we call load file. So in flowcharts, function calls or calls to sub-procedures, they look like a rectangle with these little lines on the sides here. Right? So we're going to do that. And then we're going to call save file. Okay. And then finally, the program itself, right, it's going to start. It's going to call main. Right? And then it's going to end. Okay. And I forgot to put an end down here. Right? So that's the last part of our design. And once we finish that off, we'll be able to do our test for save file and test the whole program all at once. All right, so let's update our main. What do we have to do in main? We have to ask for the file name. All right, so that's going to be a string, so we'll use the input function. We're not going to convert whatever it returns because it's a file name. It's not going to be a number or anything like that. So enter file name. Okay, awesome. And then what? Then we're going to call load file, and we're going to pass it file name. Okay, and then we're going to call save file. Okay, we're going to do that, and we're going to pass it the file name and the numbers list. Okay, which is returned by load file. Okay, so that's my main, right? According to my plan over here, that should do it right there, right? There's my main. And then the program itself starts, calls main, and then ends, right? So that's why we got our function call right there. So let's test it. There's numbers.txt before we run the program. Now let's see what we get after we run the program. Invalid syntax. Let's go fix. What do we screw up here? Oh, I forgot an opening parentheses there. So let's try it one more time. All right, so enter file name. It was numbers.txt. Okay, now let's see what the problem was. Okay, so W is not defined, right? Syntax error. So what do we need to go fix? Right there. Right. Remember, unlike me, your access specifier here, your file mode, has to be in parentheses. So don't forget that. Now let's try again. Okay, so numbers.txt. Okay, no errors. So that's hopeful. Let's go reopen the file and see if it got updated. All right, so I'm back at my text editor here, and it says the file has been modified by another program. Do you want to reload it? Yeah, because you know, you have to refresh your text editor. If you just leave it open and it makes a change to the file, you got to refresh the text editor to be able to see any changes. Right, so let's go ahead and reload it and see what we get. Huh, take a look at that. 7, 1, 1, 2, 11, 11, 12, 6. So it looks like we have success. So let's go back to the shell window and take a look at that list, right, and see if it matches up. Okay, so this was the first, remember when I was testing the load file function? This was the contents of it. So 0, 1, 1, 1, that's 7. 0, 0, 1, that's 1. 0, 0, 1, that's 1. 0, 0, 1, 0, that's 2. 1, 0, 1, 1, that's 11 because 8 plus 2 plus 1 is 11. Okay, and what else do we have here? 1, 0, 1, 1, that's 11 also. 8 plus 2 plus 1 is 11. 1, 1, 0, 0, that's 12. 8 plus 4 is 12. And then the last one, 6. 4 plus 2 is 6. So yeah, looks like we got ourselves success. So one last little bit. Let's go back here and throw in a hierarchy chart. Right? that shows us the order in which the functions are called, right? So here's the flowcharts showing our plan, right? And what I want to throw in here is a hierarchy chart, right? So hierarchy charts can be used for functions as well as top-down, stepwise algorithm refinement, right? For coming up with algorithms. But in this case, you're just saying, well, which functions are calling which and in which order, right? So my main function got called, and then what functions did it call? Remember, it called load file, okay, and then it called save file, okay, and then the save file function also called the counted function or the converted function. Right. So not a very exciting hierarchy chart, but it kind of finishes off our entire design here, right? So we've got our flowchart for our algorithm for converting. We've got our flowchart for load file. We've got our flowchart for save file, right? And then we've got our main, okay? And then we've got our hierarchy chart telling you in which order each of the functions should be called and who calls who. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.